Hello students, this is lesson U1A02. In this video, I am going to go through exercise U1A02a, which is multiplying polynomials. So in the previous video, I defined what a polynomial was. So in this video, we are going to multiply polynomials. So why am I talking about multiplication before I talk about addition and subtraction? Well, that's because you've already had some experience with this in Algebra 1 as well as with Algebra 2 when we're adding different monomials together. Okay, we always have to combine like terms. So I'm not going to go through that, but instead it is important for us to go through a little bit of multiplication, as this concept can get a little tricky when we, especially when we take into consideration there are some exponential rules that we need to apply. So let's take a look. All right, so I'm going to go through all the odd questions here in this exercise. So let's take a look here. I have 4 times 4 to the third. Now, you don't need to really evaluate what this is. I'm not asking you to figure out what the numerical value is. The goal of this exercise is to just re-express this as one term with one base, okay? Or at least the problems that are outlined from 1 to 12 here. Okay. So this is so a number without a exponent written explicitly, okay, is implied that there's an exponent of 1. So I have 4 to the first times 4 to the third. This is the same thing as 4 to the fourth. Now you're wondering, what's happened here again? If you recall, 4 to the first times 4 to the third, well, 4 to the third is really 4 times 4 times 4, right? So how many 4s are here? There are 4 of them. So that's why I have 4 to the fourth. Next, I have 4 times 4 to the 0th times 4 to the third. Now, what exactly does this mean? Anything to the 0th power is actually 1. So this is the same thing as 4 times 1 times 4 to the third. And based upon the property that was just demonstrated in question 1, yeah, we are going to be adding exponents together. This is going to be 4 to the fourth once again. So actually, another way, an alternative way of thinking about this is the same thing as 4 to the 1 plus 0 plus 3, right? It's all the same. Another way of thinking about it. All right, let's take a look at the next one. I'm going to decrease the thickness of the pen just because I am running out of space real fast. All right, so the next one here, I have 2 times a to the fourth times b to the third times a times b to the third. Now the trick here is just when we're multiplying things together, okay, you're going to be grouping them together. So I noticed I have an a here and an a there. Well, actually, I have a to the fourth and I have a there. If I were to multiply them together, I will end up with a to the fifth. The leading coefficient there has really nothing to combine with, so that remains as 2. That stays as the coefficient. So it's 2 times a to the fifth. And then I have b to the third times b to the third. That can combine together to make b to the sixth. So again, the exponents gets added together because when we multiply these terms together with the same base, the exponents just get summed up. All right, so the next one, I now notice that I have 2 coefficients here that I combine together. This makes 16. And then I have x to the 0 times x to the second. Well, that's just x to the second then, because x to the 0 plus 2 is x to the second. And then I have y to the 4th times y to the second, and that gives me y to the 6th. Okay, and then moving on. Question 9. So now I have 4x squared to the 4th power. What exactly is this? This is saying 4x squared times 4x squared times 4x squared times 4x squared. That's what it's saying for us to do, right? So without having us to write all this out, wait a minute, isn't this the same thing as 4 to the 4th times x to the 8th? And what are we doing exactly to the exponents? This is a way to think about it. This 4 to the first, right? That exponent gets multiplied, and that exponent gets multiplied. So that's a quick way of doing this, okay, if we have an exponent on the outside of the parentheses. Now, this is only true, okay, If there's a product inside, okay, the operation between the 4 and the x squared, that's multiplication. If, let's say, the operation in between was addition and subtraction, then we can't do that. And you have no idea how many times students make that mistake. So again, question 9, that just becomes 4 to the 4th times x to the 8th. Let's take a look at the next one here. So again, going by that same logic, that 2, right, multiplies with the first, 2 multiplies with 3, 2 multiplies with 2, so I end up with 2 to the 2nd, x to the 6th, and y to the 4th. Let's take a look at the next one. Alright, find each product. Okay, so here in this case, we have to apply, we have to multiply this through. And in order for us to multiply this, we have to apply the distributive property. So some people actually might not necessarily understand, like, why do we have to distribute when we're multiplying? Well, it goes like this. I'm just going to do a really quick, like, 30-second demonstration of this. So let's say, hypothetically, I ask you to multiply 7 times, let's say, 7 times, no, my mistake. Let's do 7 times 9, right? We know 7 times 9 is equal to 63, isn't that right? Well, what about this? 7 times, let's say 5 plus 4. What do you think that's going to be? Yeah, this is going to be 63 as well, isn't that right? Well, without having to go through order of operation, right, because we have to add 5 and 4 to get 9, alternatively, we could also do this. We can also end up with 63 by multiplying these together first. So I end up with 7 times 5 plus 7 times 4. This is again equal to 35 plus 28. And yes, this does indeed equal to 63. Okay, so this is just another way for us to actually multiply things out. So not every term. Now this is only okay, or not okay. This is very, very useful when we talk about things where the inside the parentheses do not share like terms. So for instance, right now, for question 13, if you notice, we have negative 2x and negative 3y there. They're not like terms. We cannot combine them together. If we were able to combine them together, okay, then we wouldn't have to use a distributive property. But because they're not like terms and we're trying to multiply them together or to rewrite them in a different way, we're sort of like forced into applying the distributive property. So let's do that now. We're going to distribute this in, okay, and this becomes negative 10 x to the 5th minus 15 x to the 4th times y. Okay? Just another way of demonstrating this concept again, I'm just going to draw another picture here. Let's say I have a rectangle, okay? Again, I'm using 7, 5, and 4, right? So another way of thinking about this, 7 times 5, or 7 times 9, because I'm trying to get the area of this rectangle, the area is indeed equal to 63, right? But the area can also be thought of as 35 plus 28 as well. So that's a distributive property, again, demonstrated in a more geometric sense. All right, so let's take a look at number 15. So again, we're distributing, okay? So this becomes 48x plus 18y. So again, when I multiply, okay, I'm going to be combining terms together. Okay, so 6 and 8 makes 48. The 6 does not get multiplied by x, okay? Just because, again, what I have here is 6 times 8 times x. We do not need to multiply the 6 twice there. It doesn't work like that. So don't make that mistake. Number 17. All right, this is where things get a little more interesting, okay? So we need to multiply these things out. And hence, there's this concept of foiling, which you guys had studied in 9th grade. So here's a quick refresher on that. So let's say if I, again, I'm asking you to multiply 7 and 9 together, right? If I'm asking you to multiply 7 and 9, but this time I'm telling you it's 4 and 3 and 5 and 4, okay? So we know that the total area here is supposed to equal to 63, right? So the total area is equal to 63. So alternatively, right, we can do 5 plus 4 times 4 plus 3. This is the same thing as 20 plus 15 plus 16 plus 12. This is the same thing. It's the same exact thing. So if you look at this, right, well, instead of drawing this geometric figure over and over and over again, every time we had to, FOIL, right, every time we have to multiply things out together like this, there's a technique called foiling. We can multiply 5 with 4, 5 with 3, and then 4 with 4, and 4 with 3, okay, to end up with that sum. And if we add these things together, this does indeed come up to be 63. So we apply that technique, okay, and this approach here is foiling. So I take these things, okay, and I multiply them out, okay. What I'll end up with is negative 24 AB, and then plus 9 AB. I'm sorry, that should say A squared, okay. And then minus 24 AB and plus 9b squared. And lastly, I have to combine like terms. So this is negative 24a squared. 9 minus 24, what exactly is that? That is going to be minus 15ab, and then plus 9b squared. So that's the answer to number 17. We're going to apply that again, and I'm going to go through this a little quickly. This is going to be negative 20xy plus 28xy minus 15xy plus 21y squared. I made a mistake again, the same mistake as before. This should say 20x squared, not xy. So my bad there. We're going to combine like terms. This is negative 20x squared. And 28 minus 15, that is going to be 13. So plus 13xy plus 21y squared. So that right there is the trinomial that results there. If I take two binomials and multiply them together, I can result in a trinomial. It doesn't always have to end up being a trinomial, as you're going to see in a moment. Okay, so question 21, I multiply them together. I'm going to FOIL. I get 18x squared minus 48x minus 3x plus 8. So what does this all boil down to? 18x squared minus 51x plus 8. Again, I repeat, okay, so I have 4v squared minus 2v plus 12v minus 6. What will that become? I will end up with 4v squared minus plus 10v, whoops, and minus 6. All right. Next, I am going to multiply a binomial with a trinomial. So how am I going to do that? Well, really it's no different because, again, I'm going to do a quick demonstration. So if I have, let's say, 7 times 9 again, is the same thing as, it's the same thing as 4 plus 3 times 2 plus 3 plus 4. Isn't that right? They're all the same things, right? So if I do this, okay, and I break up the rectangle one more time in a very similar fashion. I have 4, 3, 2, 3, and 4. Right? We can see that this is 8, this is 6, this is 12, this is 9, 16, and 12. And I add them up, okay? What will this all add up to? This is, again, going to equal to 63. So rather than going through and multiplying and drawing this out, you can, if you want, again, perform this kind of foiling. Okay? Now, my recommendation, okay, for something like this, in my opinion, I think it's actually easier, okay, if you were to list it out in this kind of like geometric setting here. If you're multiplying a binomial with a binomial, I don't recommend that as much, just because I feel like you should be able to perform the mental computation on your own. But with something like this, okay, where it's a little more involved, where the task is a little more tedious, okay, I do encourage you to draw out the rectangle like I have here. All right, so how are we going to do that? I'm going to erase this to give myself a little more space. All right, so I want to try number 25 now. So, and the way in which I'm going to approach this is I'm going to approach it by multiplying it out like this, right? So this is negative 2r, this is negative 6, this is r squared, negative 6r, and 5. So if I were to multiply them out and add them together, I end up in the same place. This is going to be negative 2r to the third. This is negative 6r to the second. This is going to be 12r squared. This is going to be negative 10r. And then this is going to be 36r. And then this is going to be negative 30. So if I were to add this all up, this will be negative 2r cubed. And combining like terms, I will have 12r squared plus negative 6r squared. That will give me plus 6r squared. And I'm going to add negative 10r and 36r, so I will get 26r. And lastly, I'm going to have minus 30. So this is going to be the product. Okay? All right. I encourage you to try out the next one here, okay? And for this, I'm actually going to do this using the foiling approach that I was, saying before. So you could have actually also multiplied it out like that, okay, distributing to each one of those, okay, and then lastly distributing to each one of these. So I'm going to approach 27 in this manner then, okay? So I'll end up with negative 42 m squared, and then I'm going to have minus 7, I'm sorry, not m squared, m to the third, minus 7m squared, and plus 42m. And then I'm going to have 12m squared, and plus 2m, and minus 12. And I'm going to add them all up. I'm going to end up with negative 42 m cubed plus 5 m squared plus 44 m minus 12. And there you go. And the 29, okay, I have 8x squared plus x minus 4. The way we approach this, again, no different, okay? So actually, I'm going to go to the next page here so I have more space. So when you multiply a trinomial with a trinomial, you approach in the same manner. You're going to draw this out, okay? And you're going to break this up in this manner, okay? And I forget what the question was. So it was 8x squared, x, and negative 4. There's no particular order to write this in. 8x squared, x, and negative 4. Let me see if I got that right. Yes. And then the next one is negative 4x squared, negative 8x, and negative 4. Negative 4x squared, negative 8x, and negative 4. Let me see, just double check one more time whether or not that's correct. And that does appear to be correct. All right, so I have everything I need. now I am just going to perform the multiplication. So this ends up being negative 32 x to the fourth, negative 64 x to the third, negative 32 x squared, and then negative 4x to the third, negative 8x squared, negative 4x, and then I have positive 16x squared, and positive 32x, and lastly 16. And I'm going to try to combine everything together. I have negative 32x to the fourth. Combine all the x cubes together, right? I have these things I need to combine together. So that's going to be negative 68 x to the third. And then I have all the x squares to combine together. All of these things. So 16, negative 8, and negative 32. So that will be, so it's negative 40 plus 16. So that's going to be 24. So it's minus 24 x squared. Combine all the x's together. So I have positive 28 x and plus 16. And there you go. And for the last problem, okay? So let's take a look at the last problem. So the last problem here that I'm going to go over, okay? I'll rewrite on the next page here. 8x squared plus 5x minus 8. So give me a second. 8x squared plus 5x minus 8 times 7x squared minus x minus 1. 7x squared minus x minus 1. 7x squared minus x minus 1. Let me see if I got that right. Yes. 8, 5, negative 8. Yep. Okay. So I'm going to approach it a little differently. I'm not going to use this like box method, matrix method, okay, to figure it out. And you're going to see that we end up in the same place. We're going to apply that foiling approach. So when we FOIL, we got to take all of these and multiply them together term by term. And I'm going to use another color here because it's going to get messy really fast. Okay, so what will happen here is I'm going to end up with 8x squared times 7x squared. So that's 56x to the fourth. And then 8x squared times negative x. So that's plus negative 8x to the third. 8x squared times negative 1. So it's minus 8x squared. Next, I'm going to combine 5x and 7x squared. So that's going to be 35x to the third. And 5x and negative x makes negative 5x squared. 5x and negative 1 makes minus 5x. Negative 8 and 7x squared makes negative 56x squared. Negative 8 and negative x makes plus 8x. Negative 8 and negative 1 makes plus 8. And all I got to do now is just add them all up. So I end up with 56x to the fourth plus, I'm going to add up all the x cubes, right? So negative 8 and 35, that gives me 27x to the third. I'm going to add up all the x squares together. So 56, 5, and 8. So that's going to be 69. So minus 69 x squared. I'm going to add up all the x's. So it's plus 3x and plus 8. And there you go.